Okay, welcome to this example. It's about coffee. The amount of coffee that people drink per day is normally distributed with mean 15 ounces and standard deviation of 5. So, so knows how much people drink coffee. The average is 15 ounces, but not everybody drinks the same, some more or less. The average deviation from that is 5 ounces. 35 randomly selected people are surveyed, round all answers, blah, blah, blah. What is the distribution? This is X, and then what is the distribution? This is X bar. So whenever we're talking about X, X is for one person. And so we do mean standard deviation. So the mean, as they said right there, 15 ounces, standard deviation 5. No big deal, no big deal. But then when we come on down here for X bar, I'll write it over here, is the average for a group. In this case, N equals what, 35? Right, it says it right here, 35 randomly selected people. So whenever you see a bar over X, that always means the average for a group. That's what that bar over a letter means in statistics. That's just our lingo, our notation. So when they put a bar over X, it means the average for a group. So just plain X is just one person. X bar is the average for a group. And in this case, the group size is 35, right? 35 randomly selected people. Okay, so what? Well, the mean is the same. That doesn't change, but you probably know already the standard deviation does. You got to take the standard deviation, you got to divide by the square root of n. So in this case, you got to take the, what's the standard deviation? The 5 divided by the square root of 35. When you hit the buttons on your calculator, you'll get 0.8452. 0.8452. Whoops. Let me try that again. 5 got a little shaky. There we go. So that's what's going on there. So when you have a group average, it changes the standard deviation. There's less deviation for a group. You can picture that, right? If I went around the room saying, hey, I want just one person at a time. I'll call your name and you yell out your test score. People probably wouldn't be comfortable with that. But anyway, just imagine it. I yell out a name and they go, okay, I got an 83. And the next person, I got a 97. Next person, I got a 62. There'd be some high, they'd be up and down. There'd be a lot of variation. If instead I said, okay, now I want you to get in groups of 10 and you guys, and I'm going to select 4 different groups of 10. And for each group of 10, I want you guys to add up your 10 scores and give me the average. Then I went, all right, group 1, what was your average? 79. Group 2, what's your average? 76. Group 3, what's your average? They'd be closer, wouldn't they? Because you're talking about group averages, there's less deviation. There wouldn't be such a jump from highs to lows because in a group of 10, the high numbers and low numbers, they would kind of average towards the middle. That's what we're observing here. When you're talking about a group average, X bar, that's average for a group, the standard deviation is going to change. You're going to have less standard deviation. It's going to get smaller. See how it went from being 5 to being 0.84. It's under 1 now. It gets smaller. That's the point. When you talk about a group average, the standard deviation gets smaller. There's less deviation from group to group than there is from individual to individual. All right. So all those formulas are in the notes. I'm going to move on. Question C. What is the probability that one randomly selected person? Okay, so you have to watch closely now on these questions because they're going to switch it up on you back and forth, back and forth. So notice I'm going to try to stay with color coding to make it clear. This is one person, which is just like part A. A and C go together. They're all about one person. Okay, so I'll bring it down here. So part C, you know how to do this kind of thing. Draw a bell curve. And and then you put the middle on there. What's the middle? Mean is 15. Okay, that's the average person drinks 15 ounces of coffee every day. And then they're saying between 14.9 and 15.4. So let's say 14.9 is right there. And 15.4 maybe is right there. So this section right there. It's probably tighter than that, but whatever. What's the chance? So this is the low number. This is the high number. And we're just doing this for one person. So We go to the online calculator. Let's go there. Let me just go back to the start. So you choose the online calculator. You go to the normal distribution number 8, normal probability, number 8. Okay, the low is 14.9. The high is 15.4. The mean, what was the mean? 15. The average is 15. The standard deviation. Now, which standard deviation you use? I'm going to use the 5 because we're talking about just one person. We're just grabbing one person at random and saying, what's the chance, if I just grab one person at random, that they're going to drink between a low of 14.9 and a high of 15.4 ounces of coffee per day? Calculate. Probability, 0.039, blah, blah, blah. So there. So it's actually a very narrow little region. 0.0399, you'd round that off to. So that's right. Let's go back. I made it look all wide on my graph, but it's actually very narrow on the real graph. Okay. So we got that. There's that answer, right? Again, that was one randomly selected person. That's what A is about. One person. X. X is one person, not X bar, but X. And for that, you use standard deviation 5, right? Because that's the deviation from one person to another one person. Now, in part D, I'm going to code D with B. These guys go together because this is for the 35 people, which is X bar. See, it's the same numbers again. So I'm going to say part D is the same graph. It's still going between 14.9 and 15.4, 14.9 and 15.4. The only difference is it's for 35 people. So for D, we're going to use standard deviation is that new standard deviation, 0.8452 for part D. That's the only difference between these parts, between parts C and D. It's the same question, right, on C and D, between 14.9 and 54, between 14.9 and 15.4, but part C was for one person, part D is for 35 people. So we're talking about a group average, you're going to use the new lower standard deviation. There's less deviation for a group than for individuals. So go to the online calculator, do the same thing, but with the new standard deviation. We're talking about a group average. Come here, the standard deviation, get rid of the P. Standard deviation is going to be 0.8452. 0.8452. 8452. Calculate. 2291. Yep, that's the answer. 2291. Let's go back. Okay, so there's our answer. 2291, as we said. Now, it says for part E, it says, okay, for part D, what we just did for the 35 people, is the assumption the distribution is normal necessary? Well, you can see the answer there is no, no. Why not? Well, it's because the group size is bigger than 35. It's because the group is 35 people, says it right here, 35 randomly selected people. That's more than 30. And so, um, so it automatically makes everything normal, bell curved. It automatically makes it a bell curve. So we do not need to be told it's a normal distribution. We do not need to be told that. So that's in the notes. If you look at the notes, in fact, maybe it'd be worth it. All right, I'll go back. I'm going back and forth a million times, but here we go. In the notes right here, it says, note, when n is less than 30, we must be told the data is normally distributed to use these formulas. When n is greater than 30, it will automatically make a normal curve, so we do not need to be told this. So that's what we're saying here. That, so we've been using the normal calculator, normal probability calculator, right? So that assumes that the graph fits a bell curve. We call it the normal distribution because that's how things are normally distributed. But not everything is distributed that way. They have to tell you, hey, this thing is normally distributed. Then you can go use the normal distribution calculator. They don't tell you that. You can't be using that normal distribution calculator. Well, unless the group is more than 30. Because if the group is more than 30, averages of groups more than 30 automatically make it bell-shaped. Automatically. They don't even need to tell you that. That's what this is saying here. When the group is more than 30, it will automatically make it, so you don't need to be told it. Whereas if it's less than 30, they must tell you, hey, it's normal, so you can use the normal calculator. So our group is 35. It was more than 30, so it's automatically going to be bell. They don't even need to tell us it's normally distributed. We do not need to be told it. No assumption necessary. Okay, so let's go back to it. Last part of the question. And Q1, Q3. So I'm on part F here. How to find Q1. And notice it's for the average of 35. So you always got to pay attention. I'm talking about one person or a group average. This one's a group average. I can go back and forth on you. So part F, you know the deal down here for part F. We got to draw a bell curve. Put the center on there. What's the center? The average person drinks 15 ounces of coffee. You know where the Q1 stuff is, about right there. Q1, Q3 is about right there, you know, point 25, 25, 25, 25. Okay, so here's Q1. So let me just a little room here. Okay. So we're going to try to find the low, which is negative 5, 6 nines. This is the high, which will leave blank because I don't know it. Low, high, 0.25. But remember, average of 35. So that means I'm going to use the standard deviation, the new one, the 0.8452, because it's a group average. It's not one person, right? It's the average of 35 coffee. So you're grabbing 35 coffee drinkers, not just one person saying, hey, what's the, you know, where are you at? We're grabbing 35 coffee drinkers and saying, hey, what's the quartile one for 35 coffee drinkers? Meaning 25% of all, you know, all right, I don't got time to explain. I think the Q1, you know, Q1, right? The into the 25%. So we're gonna go do that. So let's go to that, and I'm gonna find Q3 at the same time because that's just gonna be the 0.75, same thing, right? So here we go. Let's go to the calculator. So the low is negative 6 nines. The high is blank. The mean, the standard, we already got the new standard in there. The probability is 0.25 for the first quartile, Q1. Boom, there it is. There's our answer to that first part. 14.4299. There it is. That's the bottom 25%. So for groups of 35 people who drink coffee, 25% of those groups will have a group average of 14.4299 ounces of coffee or less. And now for the now I'm gonna now I'll do the I'm gonna change to the 7. That's the Q1 first quarter 25%. Now I'm gonna get rid of that answer, bonk, and change to 75%. Get the third quartile now, 75%. Calculate. There it is, 75%. So if you of all group averages, so if you grab 35 coffee drinkers, 75% of them will have a group average of 15.6 ounces of coffee per day or less. 15.57007. There it is right there. Got that. All right. Let's go back. And so here's those two answers. There's that one. There's that one. And then, you know, IQ, I just take the Q3 answer minus the Q answer. This and this, just subtract them. And you get those two answers. And so there we go.